All right, so I want to explain question number 5 in the prelab. It gives you mixture 4, which has 5 milliliter of 2 times 10 to minus 3 iron nitrate, 2 milliliters of 2 times 10 to minus 3 KSCN, and 3 milliliters of water. And it's asking you to calculate the K, the equilibrium constant, if you measure the equilibrium concentration of the product to be 9.5 times 10 to minus 5. And so what they're saying is that the concentration of this ion at equilibrium is that value. In order to calculate the equilibrium constant, as you learn in lecture, you have to set up something called the ICE table, which I show right here. And that just means you start with the reaction at the top, reactants to products, and then you start with initial concentration of each of the reactant. In this case, both of them have some numbers, which we'll calculate in a second. But then the product at the beginning is 0, so we write 0 right here. And the result of the reaction is you're going to lose some reactants, so we indicate that as X. So minus X for both reactants and then plus X for the product. And the reason why they're all minus X and plus X, they have a one-to-one relationship because the stoichiometry of that equation is 1-to-1. And then at the end, at equilibrium, you just add what happens initially with what the change is, which is what that letter C stands for. So when you have equilibrium, then you would have the initial concentration of iron minus X. With the thiocyanate, it's going to be SCN minus concentration initially minus X. So this should be a 0 right here for initial concentration. And then for the equilibrium concentration of the complex ion, it will just be X because it's 0 plus X. But we were told what that number is in the question. It was 9.5 times 10 to the minus 5. So we have that number. So now we have the X value. We just need to find the initial concentration of each of the iron and thiocyanate in order to be able to get our equilibrium constant. So to do that, you need to do a M1V1 calculation, dilution calculation, because just similar to what you did in the chemical kinetics experiment, you're basically mixing the iron with the other guys. And when you're mixing them, you're diluting it effectively, right? So to calculate the concentration of the iron initially, we would take what we have originally in the reagent bottle, multiply by the volume that we put in, divided by the total volume, which is 10. And we get this number for initial iron. We repeat that process for thiocyanate, we get this number. And then to calculate the equilibrium constant, we use the equilibrium constant expression, which is products concentration at equilibrium over reactant concentration at equilibrium, which looks like that. And we plug in the numbers. So for the product, it was 9.5 times 10 to the minus 5. For the reactants, it's the initial minus the 9.5. And so that's what it looks like here. If you do that, you should get 344. For number 6, which is the question you're asking too, you say you're not understanding how that number could be bigger. Well, I would not solve it for you, but ask you to think about the difference between the two equations between number 5 and number 6. And number 6, the equation that's given to you is this. So if the equation is given to you as 1 iron with 2 thiocyanate, the expression of the equilibrium constant is also going to change. It will look like product concentration over iron concentration divided by thiocyanate concentration squared because there's a 2 here. And so think about how that's going to affect, these numbers right here. So you can redo the ICE table with that 1 to 2 stoichiometry and just see how the numbers would change as a result of that adjustment in the stoichiometry. Okay? I hope that helps.